Hidden Layers. Meet the people behind the data with Uri Elabayev.
Hi everyone, thank you all for joining us. This episode of Hidden Layers will be in English because we have a special guest today, Krishna Rangasayee. I hope I pronounced it correctly. So, hi Krishna, how are you?
Doing well, Uri. Thank you.
Yes, so I'm really happy to have you here with us. I was looking forward to this conversation a lot. And before we start, just introduce yourself, what you're doing, your background, and then we will be able to start.
Thank you. Yeah. So I'm 30 plus years now into semiconductor software and AI. Been mostly in public companies. My last tenure was at a company called Xilinx. So I was there for about 18 years and learned a lot about the physical AI space and decided about 6.5 years ago to start SiMa. And it's been a fantastic journey, and I'm sure we'll talk a little more about SiMa going forward.
Yeah, perfect. So thank you for the introduction. You have a really rich background in this field. And can you please tell us a little bit about SiMa, what SiMa is developing, what the line of products, so people will be able to understand what you're focusing on?
Sure. So I chronicled 2015 to 2025 really being the time for cloud-based AI or consumer-based AI. And 2025 to 2035, I truly believe that AI will scale in the physical world. And it'll manifest itself in everything we touch as human beings: robotics, automotive, medical, aerospace and defense, smart vision systems, right? So things we really touch on a daily basis, human beings. So far, the AI participation has been minimal, but I think the decade of physical AI is ahead of us. And what we did 6.5 years ago was to really build a purpose-built company to focus on just scaling physical AI in all these market segments.
Interesting. So this is something that you will participate, that will have much increasing demand, and you sort of develop chips, right? And that will be able to run AI models at the edge.
Absolutely.
Just very complicated task models and put it on a chip.
Yeah.
Can you share a little bit about general use cases or things
Sure.
that already integrated your systems?
Sure. So, and you got it right. So we build a full stack solution. And what I mean by that is we make our own chips. We make the AI software that runs on top of it. And the large difference between running AI in the physical world is, since it's physical, you're really dealing with real world environments, right? So you need to capture data. You need to capture data in audio, video, or text and convert them, process them, and provide answers in audio, video, and text. So this is quite different than, say, your user experience in the cloud. So this term we use is called multimodal, right? So multimodal AI is really very important. We support the breadth of AI models from CNNs to transformers to now LLMs. And there's an alphabet soup of LLMs, as you know, of LLMs or VLMs or SLMs.
Too many LLMs.
So we run them all, and we run. What really made us very significantly interesting to our customers is we do things better than most companies. We run the breadth of these models, but we run them all on our single chip for less than 10 watts.
Wow.
Power is really, really important at the edge. While performance matters, like in the cloud, but in the physical AI world, power, and if not power, thermal efficiency and dissipating heat really matters. We do a really good job there, and we're in the minimum 10x of the world's best companies. And so that's really made us quite compelling and interesting. The second thing that we're really well known for is the ease of use in our software.
Yeah.
Today, just as an example, you could really take a Hugging Face repository of LLM models. You could tag the architectures we support, and whether you pick a Llama model or a Gemma model or an open source model or your own model that is in the Hugging Face environment, in a push of a button, you could run all of that for less than 10 watts on our chip. So that's really powerful. And so the combination of bringing ease of use into AI in a very power efficient, thermal efficient way is really at the very key of our innovation in the physical AI world.
Yeah, it sounds really interesting because as we can see that LLMs become commodity, there's a lot of new use cases that people want to use them in ways that maybe is not just suitable for cloud, something you want more private, more local, with
Exactly.
zero latency. This is
Yeah,
also important. Just you don't want to wait a lot to get the answer. And if we will have the hardware that will support it, it will
absolutely.
open a lot of use cases, new use cases.
Absolutely. And I would say in not having a purpose-built platform available for the physical world, you're
Hmm.
kind of thrown every problem in the cloud today, right?
Yeah.
And you hit all 3 points. And I think the reason why there's going to be a better balance in what stays in the cloud and what's going to live on device in the physical world is really going to be three vectors. One is security and privacy.
Yeah.
Many market segments cannot tolerate the security and privacy environments in the
Hmm.
cloud, right? So that's number one. Number two is latency. Think automotive, think robotics. You're really dealing with human beings and you're traveling and you're navigating things. The latency of sending data to the cloud and getting information back is not going to be acceptable for a vast majority
Hmm.
of applications. The third one is TCO, right? The cloud's actually pretty expensive.
Yeah.
And also the ability to monetize the data and really able to really do real-time processing near the data and manage the information is going to be a total cost of ownership equation too. So to combine the three, depending on your application, and aerospace and defense as an example,
Hmm.
security and privacy is of paramount importance. Latency too, you may be in hazardous situations where you don't
Hmm.
have access to the web or access to 5G or Wi-Fi. So being able to do on-device AI untethered from any cloud environment or any connectivity, but getting very highly performant LLMs or vision transformer models running for less than 10 watts is really what we do well.
So this is really, really fascinating. You started to mention the aerospace. Can you speak a little bit more about the defense? We are speaking as a part of the Defense ML conference, and I've heard a lot about your use cases in a general or more public domains.
Sure.
But as you said, the defense have its own needs. Everything has to be on point. The cost of mistake is so huge.
Sure.
So can you please elaborate a little more about that? What
Sure.
you're doing and what you see that there are demands in the field?
Yeah. And so I'll broaden the horizon and get to specifically answer your question. One is if you really think of our platform, commercial or in the aerospace and defense environment, we are multimodal. We handle real-time world needs of audio, video, text, input, output, right? So that's one thing.
Hmm.
Second, they're very power and thermally efficient compared to any other solution out there. And the third one is we really have a deep investment in security and privacy infrastructure on what we do. All of these ingredients are very valuable in commercial, but they're critical in the aerospace and defense community. So we're engaged with aerospace and defense customers, tier ones, primes globally in all the friendly nations, including in
Hmm.
Israel. We're
Yeah.
engaged with every major entity in Israel. And we are really bringing this advanced capability into the needs of aerospace and defense. And you're right, the needs of aerospace and defense are a lot more ruggedized, a lot more safety critical, and a lot less forgiving just because of the nature of the need, in that you're touching human beings and you're touching national security. So
Hmm.
privacy, security, accuracy, and being right is taken on a whole new meaning in aerospace and defense relatively compared to commercial applications.
Yeah, I totally agree. This is something also I see as part of the preparation of the defense ML itself. You see that the ChatGPT moment also affected the defense sector. And this is funny because we know the defense sector is moving really, really slowly and take years to adopt technology, especially technology comes from the consumers. But now we can see that even the soldier in the fields want its own ChatGPT version, to understand how to use it. Or now you want the missiles or maybe robots to be as a part of the battlefield. And this leads me to the second question is about the physical AI. This is something
Sure.
you are putting a lot of focus on that, the physical of AI and how it's going to be part of the new defense paradigm. Can you share a little bit about
Sure.
that?
Absolutely.
Yeah.
So if you look at every defense equipment or customer today, their equipment's been here for a long time. And as you
Mhm.
know, I'm patronizing aerospace and defense products live for a very long time. Most of them are what I would say a rule-based compute. If you really look at what's driving the intelligence behind it, It's rule-based compute using CPUs or GPUs or DSPs or SoCs.
Hmm.
In the last 5, 10 years, we have started now playing with statistical ML, right? So
Hmm.
this is edge AI based platforms where you train a particular network on a problem, and based on statistics and probability, it detects the probability of what it can be, right? So that's really been the nascent element of where AI has been. The new paradigm with physical AI is that for the first time, you're moving from rule based and statistical to now reasoning based, like human beings think. So this is the chat GPT moment for physical AI world. Is now you could now converse in an audio environment. You could converse in a video environment, like
Hmm.
human beings talk to each other. So the paradigm of, I mean, I have a keyboard in front of me here.
Yeah.
This will be an antique equipment very, very soon.
Yeah. Who
Right?
want to types? Yeah.
Who types in a QWERTY keyboard anymore, right? You
Yeah.
talk to machines, and machines talk back to you.
Hmm.
That element of human machine interface is going through a radical change. So that's one element of it. The second one is the benefit in reasoning based systems is it's way more accurate than statistical or rule based equipment, because it
Hmm.
has context, it has memory, like human beings do, and it's personalized. So when you interact with it, it learns more about you and you learn more about the machine. And just like human beings get to know each other, you get a deeper, richer understanding of the context with memory. And these have been not possible technology wise until today. So there's a massive upheaval on just every equipment being reasoning based. Today, LLMs are the representation of reasoning, but I promise you, in a
Yeah.
year from now, it'll be something else, right? We just don't know what it's going to be. And
Yeah.
AI in the space of innovation is radically shifting. And that now is really creating a disruption in a good way in the aerospace and defense community that traditionally has held on to design cycles much slower than the pace at which AI is moving. The same thing we are observing in the automotive industry too, which is also relatively slow to absorb brand new technology, or medical, right? All these massive industries that touch human beings are going through a massive over upheaval. The underlying theme is the ability to bring reasoning capability in a physical construct to help these applications.
Yeah, this will be a mind blowing you if you will be able to have a really good reason model, running in your chip in an offline environment. And this is something that specifically in defense sector is very crucial because you need to make a decision really fast and you
Absolutely.
want to understand why this decision was this one, not and the other one, and specifically understanding what caused. Every time you say AI is a black box, and this is now still true, but with the reasoning, you
Sure.
have like an ability to look a little bit inside and see what the model trying to explain itself, how it's trying to explain. And I want to speak with you about the power consumption, the efficiency,
Yeah.
because this is something you mentioned several times, because when you are in the field, every pound counts and every battery you need to charge. So
Absolutely.
can you speak a little bit about that and what are the trade-offs? And this
Yeah.
is also important to emphasize because there are always a trade-off when you're
Correct.
using low energy products.
Correct. So for the aerospace and defense community, we grew up with the term SWaP-C, right?
Hmm.
So size, weight, and power and cost, right? So these are underlying principles of what's really built for the needs of the aerospace and defense community. In my previous company, I spent all my 18 years servicing the aerospace and defense community. We are bringing all that knowledge and really saying, how do we give something the aerospace and defense community could truly leverage from a platform perspective?
Hmm.
So that's the broad foundation that I think we thought about. But you're entirely right. Power is really critical because power is also cost, power is also weight, and power is really at the underlying theme of building architectures in the aerospace and defense community. And think of it this way. I mean, you have tanks, you have munitions, you have submarines, you have border security elements. These are all equipment you don't want to throw away and really go rush into something that is very high
Yeah.
performance just for the sake of it, right? Our goal is to really fit into existing equipment. So think of
Mm.
it as our strategy is to AI enable and bring brand new capabilities into existing equipment. The
To
one way
upgrade them, to give them new capabilities.
absolutely. So we don't want to change the infrastructure. We want to improve the infrastructure.
Hmm.
To do that, you really need to be under a power envelope and a thermal envelope where you don't need safety, where you don't need cooling, where you need no change to the equipment, if you will, right? So power becomes really important if you think about it, because
Hmm.
electronics are very important, compute's really important. But if you look at the life cycle maintenance and the cost of the overall end equipment, it's way more expensive to overhaul the other things. So we do
Yeah.
not want to introduce change or bring minimal change. We want to upgrade existing equipment to be AI capable and with
Hmm.
the latest capability. And that also allows a roadmap for future upgrades where you're
Yeah.
not looking at changing the equipment all the time, every time you bring new compute. So what trade-offs are we making to make this possible, right? So there's no black magic, and at the end of the day, it's an engineering thing, and life's
Yeah.
all about trade-offs. The trade-off we are making is that we are a AI-focused compute element. We are not a general purpose CPU or a GPU. I cannot run every workload that anybody throws at me, right? But in the AI context, for the needs of pre-processing the data, post-processing the data, and doing AI compute, we are world class at it, right? So we're trading off general purpose for user specific. So that's the one big trade-off we are making. The second trade-off we are making is we are not in the very, very high end of the compute infrastructure. We are not in the cloud. We are making that trade-off. And we are not in the consumer either, where we are less than a microwatt or a milliwatt in power, right? We have picked a segment that says for power envelope of 3 watts to 10 watts, for all the compute problems that you want to fit there, we want to be the best in class in performance, power, and ease of use. So we have chosen that, and we
Yeah.
have made the trade-offs and not participating in other elements. So our focus is to be best in class in the areas where we are good at. And to a certain degree, that focus gives us strength and better superiority over other alternatives. But
Hmm.
we're making trade-offs where other companies that are focused on other areas would be better than us, right? So that's the trade-off we're making.
Yeah, really interesting perspective because you need to choose your battles. Speaking about defense, you need to find a way that you want to be good at or thing that you want to be good at. And I want to ask you if you can share. Do you have some examples or use cases in the defense? Of course, things that are not classified. You don't have to mention the name of the client that you already seen the usage of your platform in a really interesting or unique use cases.
Absolutely. So we are today engaged with quite a few customers in a variety of applications, drones.
Mm-hmm.
We are engaged in a lot of robotic environments, a lot of mobility platforms. What I mean by that is mobility platforms on land, mobility platforms in the sea, and also satellites. And every day is an exciting element of what we're being able to make possible, right? And so I'll give you some examples of what we've been able to do. We've been able to be multimodal, and you could get thermal imagery, computer vision environments, LiDAR elements, and you could bring all these modalities so an equipment can be truly operative in any environment, right? So that's really a very powerful capability because it's a very sensor
Mm-hmm.
information rich environment in any problem you're solving in aerospace and defense. What we've also been able to do is really build redundancy and accuracy so that people could double check and really ensure that they're doing the right thing or the right decisions are being made with the information being captured.
Mm-hmm.
Our power efficiencies allow people to really pack a lot more intelligence into the chip and really stay within the thermal power envelope. So this is why satellites are a great consideration for us because
Can you give an example how satellite use your chip
absolutely
and
yes.
what they now can do that wasn't possible before?
Absolutely, right? So satellites, just imagine you're hovering around Earth, you're capturing a lot of images that are very
Mm,
high density. You're looking for the highest order bit change detection. You want to say, hey, I
okay.
took a picture and I want to see the difference and I want to identify a class of objects that I'm interested in. Okay. Previously, your only ability to do it would be to throw a very high performance CPU or a GPU that I think could do the analysis, or you would transmit the entire information of
To
the previous
Earth.
image or the new image down to Earth and then retransmit it back, right? This is battery, this is compute, this is latency, and you're
Yeah.
losing a lot in that element. Today, with our chip, what you could do is capture the image, capture the new image, do the detection of the delta, and if they're
Locally on the satellite.
on the satellite at a very, very low power, and transmit only the information of the delta to the needed
Mm.
entities.
Wow,
So it's all of this, right?
that's
So
really cool use
dramatic
case.
shift in latency, dramatic shift in intelligence, and a dramatic shift in terms of cost, right?
Yeah, but also the cost. Now I'm thinking about out loud. The cost of the launching the satellite. If you have less, let's say, instead of huge CPU or GPU, you have this small device. Even the cost, there's a weight, the formula, how much it costs per weight. So now you can
Yeah,
even
instead of
as an
sending a
outcome.
100-watt device, you're sending a 10-watt device that needs no cooling, and you're in the space environment, and you're just doing analytics, and the information being passed up and down is really information of the delta in the information.
Mhm.
And if there's no delta, then it sends a note saying no change, right? So it really is
Yeah,
moving from data movement to information management. And
yeah, I
so,
really like that
but
phrasing.
think of it the same way in any environment you're
Yeah,
on.
in drones also. Yeah,
Drones power is everything, right? And flight time is everything. And
yeah.
every milliwatt you save in power adds to flight time. And
Yeah.
what we've also been able to do with drones is really look at a wide set of imagery and create new compute platforms and do things that you could never get done before. Because as the algorithms are getting more complicated, you're needing more compute, and you're being limited by power, right? So this is true
Hmm.
in robotics, true in aerospace and defense, and true in drone applications, which really are a good poster child for our technology. And the last benefit I'll come back to and tell you is AI is shifting once every 3 to 6 months in new architectures, new capabilities.
Yeah. New model,
Silicon
new, yeah.
platforms take 3 years to really upgrade, right?
Yeah.
Typically. And aerospace and defense platforms are 5, 10 year cycle in upgrades. So
Hmm.
connecting the dots and making sure that you stay relevant in the latest AI technology really means you need to build a silicon that is power efficient, but also capable of future proof upgrades,
Yeah.
remote
So no
upgrades.
matter what a new model will come or any new
Absolutely.
architecture, you can just burn it to the chip or just update it and that's it.
Absolutely. And as somebody said, the only constant is change, right?
Yeah.
So you need a system that's relevant because you don't want to ship equipment that's going to be obsolete in 5 years from now. So you
Yeah.
really need to build a system that is going to stay relevant. I mean, if 5 years ago you did something in CNNs, and today then it became transformers, and you don't know have a migration path for LLMs.
Yeah.
The beautiful thing with our product is you could do all three in the same chip.
Ah, wow. You can use CNN to Transformers because I
Absolutely.
know that many other companies, including competitors, said, "Oh, we only support CNNs. We have not yet launched a product for Transformers and stuff like." Every new model architecture is a new chip or a lot of new work. So in that case, you can just use that in any models you
And
wish.
so LLMs are today challenging a lot of
Hmm.
architectures because most of them are built for CNNs and for transformers. We better architecture knowing that transformers are the underlying backbone for future AI development, at least for the foreseeable future. So today we are one of the few companies that really can support LLMs with a click of a button. You really don't have to worry about migrating architectures from transformers and CNNs into LLMs. And to us, it all works in the same chip. And today, we are running an 8 billion parameter Llama model for 7 watts.
Oh,
So
wow.
completely self-contained and very highly accurate. And no doubts, as you go less in parameter model size, your performance and power will also improve. But that's a very powerful capability for that class of a problem. And we also enable software environments where what's called a RAG infrastructure, a
Yeah.
retrieval augmentation infrastructure. I'll give you a simple example. You're in an aerospace and defense product. These systems are very complicated. You're assumed in the field and your equipment has some issue, and you want to find out what the issue is and how to go look to. Typically, there's a 300, 400 page manual you get trained on, and very, very best know exactly what to go do, right? It's no different than you seeing a yellow check light on your car dashboard when you're driving. Nobody
Yeah.
reads
Yeah.
manuals.
Good luck with understanding them. Yeah.
Nobody reads manuals anymore, let alone complicated equipment, right? Just imagine you could now talk to your machine, that has
Mm.
now been fed with the RAG infrastructure. You train it on the documentation. So it knows everything about the equipment. So you could say, hey, I have this problem. Give me two or three suggestions for what I should do. And it will tell you exactly what to do. You
Oh,
don't
this
need
is
to
an
know
amazing
anything
use
about
case.
it. So think about how efficient it's going to make everything around the world, right? And we are seeing this happen in every equipment. We are seeing this in lawn mowers. We are seeing this
Mhm.
in refrigerators. We,
Yeah.
and this is going to happen in the aerospace and defense community where support and remote support is a big burden for all of our customers. LLMs are really going to completely reshape what's possible because you'll have an expert AI sitting right next to you, giving
Hmm.
you every context that you want to operate the machine, to understand the problem, to debug the problem. And that's really going to be a game changer for all customers going forward.
Yeah, I totally agree. You mentioned several times about multimodality, and this is something that really fascinating because if you want to use even robotics as a co-partners to humans to do any kind of activities in the battlefield, but even not fighting, just helping to um take stuff from a truck. You need them to understand the sounds, the video, the conversations. So this is something you also support, right? This entire
Absolutely.
kind of
And
input.
so we are one of the few companies that are truly multimodal. I'll give you a simple example, right? So I'll
Mhm.
use a car as an example, but you could look at it any aerospace and defense equipment. So think of an AI assistant in the car that's listening to your tires, that's listening
Mm.
to the audio that's about tires, and it gives you information on tire tread or predictive maintenance on, hey, I think your carburetor needs tuning or your oil change really needs to come around. That's the audio element of it. And just imagine that visually you're driving and you're looking at driver assistance, where you're looking at level 2 plus class of driver assistance, where
Yeah.
it's navigating the car for you, right? That's a video, LiDAR, radar rich environment. The third one is really it's texting you, hey, you may have this problem. There's a dealer right here in 15 miles. Do you want me to take it? So it's really reshaping audio, video, textual,
Yeah.
rich environment. Your cars are going to be radically different in 2, 3 years. But think about tanks, think about submarines, think about space equipment, think about
Yeah.
helicopters, think about planes. Everything is going to change from a human machine interface. And
Yeah.
that's
Yeah.
one
No,
element of it, right? And I know I'm speaking over you. I'll make just one last point there.
no, it's okay. Yeah.
And the reason why it starts with the human machine interface is because that's been a huge bottleneck in all these systems all along. But the next easy thing is think about the accuracy and the benefits that reasoning architectures are going to bring. And so
Mhm.
I truly believe that we are into a rich age of innovation and a rich age where in 20 years we'll look back at today's equipment and laugh and what we're
Yeah.
thinking and driving around things or like I said typing things on a QWERTY keyboard, and
Yeah.
so all of this is for a massive upheaval, and we really want to be a company that's at the very core of enabling this innovation in aerospace and defense and in other communities.
Yeah, it's really fun because you said once you said the example with the tires, I said, it's taking too much energy or computing to listen to the tires. This is such a niche, and but then having our conversation when the cost of intelligence is so low,
Yes,
efficient energy and cost wise,
absolutely.
the dollars. So why don't you listen to the tires? So if now you have a chip that can do multiple tasks, can do that really
Absolutely.
efficiently, now you can. It's okay to listen to the tires. Why not? So now
And
it will open new opportunity.
yeah, no, and 100%. And predictive maintenance is also a very big problem in the
Yeah.
aerospace defense community. And we are bringing multimodality to it. We are bringing visual inspection from a video image
Hmm.
perspective, combine that with audio. And you now could say, hey, in 2 months, this will need an upgrade, as
Yeah.
opposed to failing in the field and then looking for an upgrade.
Yeah,
Right?
in the combat field, it's really crucial, to know in advance because you don't always have the workshops or in the mechanical tools to fix it. So this is the main element. Once you have this tool that allow you to do all those computation that you probably won't be doing that because it costs you a lot, energy, time, money, whatever. So now, why not? And this is
Yeah.
something
So
that will change a lot of industries.
I shared this in a different context is that we have so far been limited by compute capability in our
Mm-hmm.
imagination, what we could do. And so we are really now creating a platform that opens up a plethora of new possibilities that we could never comprehend before, right? So far be it for me to know exactly how the world's going to really go evolve, but it's a very innovative set of customers we work with. And what
Wow.
we want to do is really enable the best platform they can get so they can bring their creativity, they can bring their innovation and build upon what we do. And so we want to provide a very software flexible and a very programmable environment for people to really play with and then innovate and really make great products out of it.
Yeah, sounds really amazing. And I want to ask you a few questions about the future. So, what do you think will be the future of edge devices? With all this new advantage of using those, and also, how do you think it will affect the defense sector? I think that you
Sure.
will see right now trajectories about new use cases, new technologies will emerge. So, how those two things combine together?
Absolutely. Yeah. I should not pretend like I've seen the future. I should guide you and the listeners that it's a perspective. I've studied this for a long time, and I would say two things are going to happen. I think we're going to find very strong, efficient ways to AI enable existing equipment. That's a given. I
Hmm.
think AI will live in every single aspect of our lives, including in the aerospace and defense
Hmm.
community. I cannot think of a future where AI will not be in the middle of everything, right? So that's one element. But it also, I think, with all new technology disruptions, it's going to bring new capabilities and new possibilities we never thought possible, right? So 20, 30 years ago, concept of a drone would just be impossible to imagine.
Yeah.
Right? We never knew we could really navigate such complicated perception guidance problems in a power form factor that you could really fly and really do something for 30 minutes or 40 minutes. Similarly, I think you're going to see multimodality embed itself in every equipment that we look to. And
Hmm.
you're going to see very power efficient architectures that come together that are going to reshape what we do, right? And so I'm not necessarily in line with effectively the latest and greatest evolutions, but I
Hmm.
think people want to protect their soldiers.
Yeah.
People want to make sure that the soldiers have the best knowledge base, best context around everything that they do. And I believe what the soldier wears, what the soldier is going to see, what the soldier is going to be guided, is going to go through a radical transformation. So there will be a
Hmm.
lot of personalized compute that is going to reshape what's possible for soldiers in the field. So that's one element that clearly is going to happen. That is going to
Interesting.
open up brand new paradigms of what's possible, right? From visual elements, audio elements, textual elements, and also being untethered from society and how do you really navigate yourself. That's one class of problem. The second one is really how information is exchanged between machines is
Hmm.
going to go through a massive transformation. Today, I would submit to you, it's very legacy rich and very protocol hindered. And think of a seamless way where an entire network of equipment, and if you're in a defense community, you want your Air Force, you want your Navy, you want your Army to really all be tethered together with the same context and same knowledge base. Today, it's too many disparate systems, too disconnected, too difficult to really share information and share really data between all of them. That is going to go through a massive transformation because AI is going to bridge through disparate systems in a more efficient way than ever possible. So it's going to be a radical overhaul of how things get connected, right?
Right. Interesting.
And the third element, which really no doubts is going to happen, is you're going to see brand new paradigms in more cost efficient, more power efficient, more nimble, and faster cycle times in production. And you're going to really see innovation come at half the speed that it normally takes today
In the defense sector,
in the defense sector.
it usually takes time. Yeah.
Things that took 5, 6 years would be done in 2 years. And
Wow.
people are going to find creative ways because people want to keep pace with AI's innovation. And I think gone will be the days where they take 20 years to design an aircraft, 15
Yeah.
years to qualify it.
Yeah. And then billions of dollars just to understand
Yeah,
it's not there.
and the capital intensive nature of all of it is going to reduce because
Yeah.
people will be more about nimble cost-efficient infrastructure rollout. So there will be new things we touch and do that we never think of or can imagine today.
Yeah, really interesting. I really like the second point. I never thought about that way, just machines to machine. We always think about machines to human and how we will interact and yada and
Right?
all that. But yeah, machine to machine, most likely that it's important for them to speak with each other much
Absolutely.
fluently than they will speak with us. Yeah.
Yes. No, and I have to caution anybody listening that it's not like the machines are going to become terminators. And
Yeah, yeah, yeah.
I think end of the day, what we're doing is just math. Okay, it's nothing more sophisticated than that.
Mm-hmm.
It will still be controlled and managed by rules and guidelines and ethics and what human beings want them to go do. But
Mm-hmm.
the opportunity to really be in a more rich aware, context aware, memory aware environment will definitely make the machines more efficient and our ability to interact and work with those machines way more intelligent.
Yeah, I agree. Yeah, I think that people really, like to imagine Terminator, but at the end of the day, the machines will just exchange logs or stuff like that. That really boring. So nothing will be bad. So you know what you mentioned about the challenges, and I want to ask you about that to conclude. What do you think will be the challenges, in edge device, especially with all the new physics that we need to understand how we can shrink that and improve that, and also the perspective of the defense sector. So
Sure.
what will be the challenges in
I,
the edge
I
device?
actually think there are not too many companies focused on the needs of the aerospace and defense community. We are one of the few companies where it's a cornerstone for what we want to go do for helping friendly nations really ruggedize their aerospace and defense equipment. So we have built a company where the longevity of the product cycle we completely understand. The testing, the ruggedization, the qualification process is something we truly understand.
Mm-hmm.
And these are going to be problems in edge devices because you don't want a device that's only 4 years available. You want something
Yeah.
that's for 12 to 16 years. You want reliability testing to really ensure that it can live in hazardous conditions, temperature ranges, stress testing, right? So we really are built for that. So there is the physical element of the needs of the aerospace and defense market are very different than commercial or industrial
Mm-hmm.
markets. And we are one of the few companies purpose built for the needs of the aerospace and defense community. That's one. The second challenge I think the industry is really going to have is AI and its innovation is just at a very different pace and cycle than the traditional needs of aerospace and defense and the cycle
Yeah.
they operate. No doubts people are going to innovate and find clever ways to intercept so that they have the access to the latest and greatest AI capability in the equipment that they have. But
Mm-hmm.
today, I would say it is not that easy. And that's a massive challenge in terms of system software thinking, system upgrades, and how do you really go ensure that you look to. The third element is with every new technology, there's really opportunities for how you really manage privacy and security better. And
Mm.
cybersecurity and AI, if managed poorly, could really hurt more than help. And so there needs
Yeah.
to be a lot of attention paid to privacy, security constraint, ethics, cybersecurity, hacking, preventing systems from really being hacked because you're going to have now a plethora of devices that are out there and vulnerability will increase as you increase the volume of exposure, if you will, right? So
Yeah.
with every new thing, there's always new problems to solve.
Mm-hmm.
I'm sure human beings will find a way to derive the benefit and then address the problems that they have. But there's no free lunch. I mean, every
Yeah, of
new
course.
thing introduces change, and change inherently brings new complexity. But I bet on every one of us to really figure out how to manage the new challenges that we're getting into. But the new benefits we're getting, I think, is going to be a super exciting phase to observe, particularly in the aerospace and defense community. And in Israel, we are delighted to really engage with every major entity there, uh,
Mm-hmm.
and also various customers, and always amazed at the speed of innovation and the rate
Yeah.
at which technology is adopted in Israel. So we're very happy to be active participants there. And I also have to thank you for the forum to really give you our vantage point so we could
Yeah.
share with you and the listeners our vantage point. And I hope that everybody found this to be a useful session.
So thank you very much. It was really, really interesting. I believe we can set in now for hours to speak about that because so many things that to speak and see how things will change the effects now that you can use AI in a much easier way. So thank you again. You, SiMa.ai, Ashok will going to speak about what you are doing in all this fascinating technology in our conference. So stay tuned. Again, thank you very much. It was fascinating, and that's it for now.